Thanks for this introduction. Some words about ourselves. So my name is Christian. I'm a PhD student from Bochum, and I'm also a founder of the HackManage GmbH in Germany. We're doing pen tests and security audits and so on. And I'm doing this talk together with Christopher, who started his PhD also in Bochum, and also Vladislav is in the audience, who's also done an important part of his work. So, as you might guess, this talk is about XXE and DTDs and so on. So, we're talking about XML. Okay, so some motivation. XML, you can parse it. You have to parse it if you have to work with it. So, what could probably go wrong? It's just XML. As we might have seen in the last years, there were a lot of problems when parsing XML. So problems are known since 2002, as far as I know, but even in 2016 we can still find vulnerabilities. The most famous one maybe is XXE, so XML external entity attack, which allows you to read some system files you shouldn't be able to. And we asked ourselves, so what's the problem behind it? So why do we still, 14 years after we've discovered all these problems, why do we still have to handle with them? So what's the reason for this? And in this talk, we try to find an answer for this. First, I will give you an introduction to attacks, which is maybe most useful for pen testers. Because if you're trying to work or test some XML application, you should really test for those attacks. And the second part given by Christopher is an evaluation of XML parsers. So he took a vast number of parsers and looked if they are vulnerable in their default configuration. And I can say that the results are really impressive. Okay, so let's go back to the foundations. XML has some really nice feature which enables all the attacks I will present. It's named document type definition. So document type definition is basically a kind of grammar for XML. So you can describe, for example, there is a document, it has some child elements, some sub-elements, you can describe the data that is contained in it, and so on. So it's a grammar. But it also has some features. To motivate these features, just suppose you own a nice car and you have a garage and you are managing it with some XML file. So this is quite easy. Okay, we have a simple XML file and we have our content in it. However, if you are like most people, you have a lot of cars, and if you have so many cars, you somehow need to manage them a little bit more efficient. So this was the initial idea of entities. So what you could do is simply, you could see parts that are used more often. And you can handle this by using a document type definition, and you can define some entity, which is basically a storage unit. So for example, in this case, we define this entity car, and we assign it some string value to it. And what we can then do is we can simply, instead of using the string Ferrari, we can simply use the entity. And this is quite useful if you're having large XML documents and you're reusing larger parts. So that's the initial idea of it. So you might ask, what can go wrong? What's wrong with it? So there are a lot of attacks abusing document type definitions. So XML external entity is the most famous one, I think, but there's even more. So the topic of this talk is just XXE, but there are a lot of more attacks, and they are commonly referred as XXE, although they are sometimes denial of service or server-side request forgery. So there's a lot of things you can do with document type definitions. So let's first have a look at denial of service. So this attack is known since more than a decade of years, and it's famous for its name, the billion laugh attack. You might guess an idea why it's so called when we come to it. So let's suppose we have an XML document and it defines multiple entities. And the trick here is that they are recursively defined and reference each other. So what happens if you dereference the entity C, it will be looked up into the document type definition, it is found, and it's replaced by its value. But in comparison to the previous example, it's not just a simple string. There are more entities defined. So the parser will go on, it will find a new entity B, it will be replaced by the entity value, and so on and so forth. And finally, we receive at the last entity, and it's replaced by some string. So this is the basic concept idea of the billion laugh attack. So this is not really a DOS attack, so you might guess, oh, what's the problem with it? But if you increase the number of recursive entities, and if you increase the number, or if you increase this number, then the document grows larger. So the impact is quite huge. So you can really define a small number of XML bytes, not parsed XML, just a string, a small number, and it will be expanded to a large number of gigabytes or even terabytes or whatever you like. So you can easily consume more memory than is available on every server in this world. It's no big deal. Okay, that's the easy thing. I think a lot of people know this. So what can you do to counter it? So you might just think, okay, we need this basic storage unit, but what you can do is you can simply say, we forbid recursion. So everything is fine, yes? The thing is, it's not fine. There is a variant of this attack named as quadratic blowup, which simply does the following. It does only define a single entity, or 2 or 3 or whatever you like, so no recursion, but the string that is defined is very long. So for example, take as an example, it's 1 megabyte. And what you can now do is, you can refer it multiple times. And each time it's replaced by the original entity string. So if the original entity string is 1 megabyte, you refer it 100 times, you have 100 megabyte. And the original XML document is quite small in comparison to the expanded one. So this is one feature. So you might think you could also just limit the size of the XML. So I just allow you to submit, I don't know, some kilobytes, let's say, or just say some bytes of XML, so that you cannot define larger strings, you cannot do quadratic blowup. But this also does not prevent all attacks. So what you can also do is you can use another feature. So this entity looks very similar to the one that I've defined before, but there is another keyword, system. There's also another one, public for the experts, but we keep on with system. And what it basically does is, it does not take the string that is defined there, it dereferences the string. So there's a URI, and it simply downloads this file. And you can guess what happens. So this file is downloaded, it can be some mega, giga, or terabyte, or whatever, and it's now included in the XML. So you can even reference some public server so that your own attacker server is not using any resources, and the XML file is growing up. There are even much more techniques for denial of service, and during our research in the last years, we discovered a lot of knowledge is spread over the net. So you can find blog posts and Twitter feeds and so on, all summing up some vectors. And what we tried is to give a cheat sheet mainly for pen testers, so that they have an idea on what they can do if they counter some problems or if some attack is not working. So if you're interested in more techniques, not only for DOS, but also for the other attacks, I strongly recommend you this blog post. Okay, so let's have a look at a more critical attack, I would say. So let's talk about XML external entity. And before we talk about it, let's have a little look. So suppose we have some config XML file. And what we want to do is we want to parse it somehow. So let's write a small script to parse it. Okay, so how can we parse it? I just decide to use Perl, just because I can, to write a very small script. Okay, so we use some libxml library, and we define some file, the config.xml, and what we are now doing is we are parsing it, so let's use the parser. Okay, and what we now do is simply we print it. So we print the value, so hello OWASP should be printed. So DOM, go to document element, go to text content. So there is an error. I think that could work. So let's try it. And as you can see here, we simply parse the string. Okay, so this is quite simple. This is no attack. Now we're editing the XML file, and what we basically do is we add some doc type. So doc type, and we define some entity. Let's call it file, and let's say it's an external entity by the keyword system. And let's use, because most people use it, passwd. Okay, then we have to close it. The syntax should be right. And now we have to append it. Okay, so let's use this file. Okay, I'm fine. And let's use Perl to parse it. And what happens is, instead of writing the bytes that I've printed, basically, it's dereferenced and we see the whole content of the etc passwd file. Okay, so let's have a look, just a short look at the parser again. So all I did is simply, I want to parse some XML file. And if I'm a developer, that's the reason I go. So I'm just using some library I set up and parse it. And this is not secure because you can do a lot of things with it. Okay, so let's go back to the presentation. Now you might think this is very uncommon. So let's suppose about a more real example. So suppose there's a server which offers you some nice service. So it offers you an image conversation, you can upload some SVG, and you can download some PNG, for example. So if you upload this XML file, which is an SVG, you simply get some image. Okay, that's nice. And if you do the tricks that I've used in the parser right in the live demo, you can just simply use your code, your vector, you submit it, and you will get an image containing the data of the file. So this is basically bad because it's a server. You can read the files on the server. This is what we call critical when we do something in a pen test. Okay, so this is what all people know about XXE, or most people know about it. So you might think, well, that's quite easy. So what's the thing? The thing is, let's try something different. So what happens if we don't want to read this? I have to edit the config file. If we don't want to read the passwd file, but another file. So let's read fstab. So another file shouldn't be a big thing. I only need to change the parse. So let's use Perl again. And whoa, something strange happens. So we have a parser error, and we do not get the content of the file. It's not displayed. Well, this is a huge difference. And when you're starting with XXE, you think, well, it's always possible. But in fact, it's more complicated. Okay, so it works, for example, with passwd, but it does not work with fstab. So the thing is, the file etc fstab looks, for example, like this. And maybe you see something in it. So what you can see is there are some parts which look like XML, but basically they are not valid XML. And because they are not valid, the parser will give an error and say, well, I cannot handle this. It's not XML. I expect XML, and I cannot do anything with it. So basically the problem is that we have this starting tag, which is not closed anywhere in the file. And it's even more complicated, but let's keep it simple. Okay, but I will give you an idea how to bypass it. So if you want to read the FS tab, you have to use some trick. The basic trick is quite simple and uses another XML feature, which we call CDater. So CDater is a possibility to add arbitrary content, or almost arbitrary content, to an XML file. And what we have to do is simply you have to use a starting CDater tag, then you can place arbitrary content here, for example, even these special files that lead to an error when you're not using CDater, and you have to close it here. Okay, so if you want to use it, you could think about doing it as follows. So you want to read the etcfs tab file, and you define some start and some end tag, basically to define the CDater start and the CDater end. And the idea is now to put all three together so that you have a valid XML. Okay, that is pretty nice, because if it's parsed, you will get a data and the content of the FS tab. It would be quite nice, but as I told you, it's just the idea. In real life, it's more complicated. So it's not, for example, allowed by the specification to include an external entity in combination with internal entities and to define this entity like here. But the idea, keep the idea in mind, we use CDater. So to do a real exploit, you have to do a little bit more. So what you do is you submit an XML file which does not define this, what I showed you before, but another thing. It simply loads an external document type definition from some server, for example, from my own Integra server. And when the server parses it, it retrieves from attacker.com the document type definition, and it basically looks the same as in the previous slide, but with one important difference. There are these percentage characters. And this is a special part of document type definitions, which not all people know. It's called the parameter entities. And it's quite powerful, because by using parameter entities, you can now read, for example, FS tab. You can now combine CDater with some system file content. Okay, and it's defined right here, so we can use start, file, and end. And when we return it, we just get the content back. So that's a trick. Now, we make things even more complicated. So what happens if we don't have an echo? So suppose we're uploading an image file in SVG, and we don't get the PNG back. We just store it, for example, or I don't know. Or maybe you know single sign-on, you know I'm a fan of single sign-on, and maybe you know SAML. If not, it's no problem. So what basically happens is you send some login token in XML to a server, and he said, yes, you're logged in, or you're not logged in. So it's quite simple. You can be either logged in or not. So this scenario is somehow comparable to, for example, blind SQL injection, where you don't get feedback. And it's also known by the name out-of-band attacks. It's still possible to exploit it. It's ugly, but it's possible. So I first give you the idea how to do this. The basic idea is you will load the content of a file as before, and now you have to somehow send it to your server as a get parameter. So this is what you're trying to do. Load some content and send it back to the server. Okay, so it's not working because, oh, I'm sorry, once back. It's not working because of the same problem. External entities are not allowed in this case. So we have again to deal with parameter entities. Basically, it looks very similar to the attack before. We send an XML and we just refer to some external document type definition. And what we now do is the external type definition looks a little bit different. So first we use a parameter entity to load some content file, and you might see that I'm not using FS tab or passvd, but using image size. I will come to this back later. And this is just a file with a very simple file. And what happens here is we define a new parameter entity, and this looks a little bit strange. It's not an external parameter, there's no system, but it looks like we're defining here a new entity inside a parameter entity. This is possible. This is the idea of parameter entities. And this entity is named send. You may see it's over there used. It's an external entity, and here we again find the content of the file. So if this DTD is parsed, what basically happens is we define an entity send with the attacker server, and we add the content of the file as a get parameter. And now the server performs a new request, not back to the client, but to the attacker server. And the attacker server gets, on a log file, for example, the content of a file. So this is a way you can even read files if there's no echo, if you have a blind scenario. Okay, so why are entities a problem? So there are a lot of things you have to keep in mind. So for servers, it's really dangerous because with this attack technique, you can read very sensitive files. So containing credentials, for example. It's also possible to do some URL invocation. So for example, if there are services running only on localhost, which are not accessible from another service, on the server, you might send a GET request to do some things. Maybe you can shut down it. It's the toy example, of course. Or you can do other stuff. And there's even more. It's not only restricted to the current server. What you can also do is server-to-server communication. So you can contact other servers and, for example, try to detect what network is used, are there open ports, and so on. So you can do a lot of things. And what's often overlooked, it's not only a problem for servers. So on the client side, it's the same problem. If you have some client application parsing XML, for example, you're reading a config file, you have written some tool to store, serialize the content, and then the same problems appear. So you can basically send a message to the client and you will get the content of its notebook or whatever. Okay, so there are even more attack techniques. So this is a quite long topic. You have a lot of different techniques. So besides parameter entities, there is also XInclude, which is very similar to DTD. It's basically the same idea. And while parsing XML, you should also have a look at XSLT. So we've also already heard something about XSLT here at OWASP. So you should also check if you have possibilities, for example, to include some XSLT. And if you're interested in more things, you can just talk to us in the break. Okay, that was my part. Now Christopher's giving you an idea of the parser evaluation.
So, hello, can you hear me in the last row? Okay, great. So for the parser evaluation, I also want to start with a quick motivation as to show, well, Christian also already showed you an example of an XXE attack, and it's going in the same direction, but for a specific parser. So I'm choosing Piccolo. It's a Java parser, and as you see here, the first point is usually you use a factory in Java, but here you can't do it. Well, you can do it, but if you black out, if you use it with a sex parser factory, you cannot harden the parser, and so therefore, right? So here I showed you this. We use a factory and we use the get feature and retrieve external general entities. So it's a security relevant DTD feature to disable external general entities. And then we set the feature to false, and then we check what's the output, and the output is still true. So this is just to demonstrate that it's not working with the factory. Therefore, we have to use Piccolo directly. So here we instantiate it, and we assign a default handler, and then we parse it. This is quite similar to the example Christian just showed you. And here we parse a file, standard XML with a data 4, and then we print it out, and as you saw before, the output is of course 4. So now if we do, well, a malicious XML file, here the XXE attack, we already discussed it, so you get the content of the files which are referenced here. And now we're coming to the new part. You're a developer and you want to mitigate these attacks. So you apply a feature, set feature external entities to false, and this attack is mitigated. However, now you're also still vulnerable to denial of service attacks and to URL invocation or server-side request forgery attacks. And what we did in this evaluation is we investigated these features in really a thorough manner and checked what are the implications and which features do you have to apply to be secure with your parser. So this is like the contribution of this part. So first, the test setup. We tested 28 different parsers in Ruby, .NET, Python, Perl, Java, and what did I forget? PHP. And we tested for all these attacks, which we already discussed. And the methodology was like, you have first to start with one parser and then evaluate which attacks and features are working in which way. So this is like the empirical factor of this test methodology. And when you're looking at a new parser, you have always to cross-reference to parsers which you previously evaluated, not to miss any new tests. And when you did the new parser, you have to check the old parser and the old parser to the new parser. So you always have to check and do it iteratively and incremental. And if you want to say it in real simple terms, we read the API and did trial and error, but well, it's not entirely true. I have like such a long list with, I don't know, these 1,000, where are these? 1,107 tests, which were accumulated over time. And these consist of 16 core tests, which are applied to every parser, and the core test is, for example, this XXE vector. And then we also executed additional tests, which are like you have to check which features does a parser support, and by this you have to choose your additional test. We will use the following simplified test metric, a base vulnerability score, which indicates the default behavior of a parser, and the total number of vulnerabilities, which should be self-explaining. So you can ask on more on this later. So for Ruby, we tested version 2.16, and we did ReXML and Nokogiri. Nokogiri is based on the libXML library, and ReXML is implemented solely in Ruby. So for the results, we have on the one side ReXML with only 2 vulnerabilities, and you see it's only vulnerable against denial of service attacks. For Nokogiri, you're also only vulnerable against denial of service attacks, and you have a very low base vulnerability score. However, you see this red bar here with 28 vulnerabilities. This is like if you enable security or some of the security critical features, you can really mess up your parser and end up being vulnerable against like any attack there is. So for Python, that was too fast. We did E3, XML, Sax, Pulldom, and LXML, as well as Minidom and diffused XML. And the first 3 are in the standard library, so it's obvious to test them. LXML is a very popular parser, and diffused XML provides a module for with secure configurations for each of the standard libraries and LXML. So it was pretty interesting to check if these promises are kept by this parser. So here you have the overview. We start with the secure, the most secure parser. It's diffused, and you see you have a base vulnerability score of 0, and only if you enable one feature like XInclude, you get a problem. But if you don't do this, you're safe. So this is a good recommendation for you. Then if you decide to take eTree or Minidom, I just put them here together. They don't share a code base, but it's just they have the same vulnerability scores. So they're both vulnerable against denial of service. And you see, you don't have any features which you can mess up, and here's only the XInclude features which could make any problems. For XML sex and pulldom, it looks a little different. You are vulnerable against 9 attacks, both, and denial of service, XXE, and server-side request forgery. And pulldom internally uses XML.sex. So yeah, it invokes this one. This is the reason why we put them here together. And last but not least, LXML is vulnerable against denial of service and XXE. However, as you see on this red bar here, if you enable any features, you can also mess up the parser configuration pretty heavy. So always have this button here like details Ruby. This is just for the question section. If you wanted to know any details on a parser, we can talk about it. So otherwise, I will show you maybe something from Perl or Java. Then we did .NET. There's XML Reader and XML Document. XML Document implements the DOM API, and XML Reader is an abstract parser class. So there are other specific parsers, but Microsoft discourages its use. And this is easily seen here. For XML Reader, you're basically totally safe if you use it with the default configuration. Again, if you use a specific implementation, these are configured differently, and you might be vulnerable, or you're vulnerable against more attacks. Then for XML Document, it looks worse, because you got here a base vulnerability score of 10, and you're vulnerable against XXE, parameter-based XXE, and server-side request forgery. So PHP, we did the simple XML, DOM document, and XML Reader API. And yeah, it's like they are offering tree access to the document, and the other one is a pull parser. Starting with XML Reader, this is the secure choice for PHP. So you're by default secure. However, if you enable features, and there are also other problems with this parser, like with the features themselves, they're implemented differently, the parser-specific features and the features based on libXML. So here you might face some problems. And for simple XML and DOM document, you're by default vulnerable against denial of service. However, here again, if you activate the features, you got more problems. So Perl, we've already seen this today. XML libXML is the parser based on libXML, and XML Twig is another Perl parser. And you see here for XML Twig, it's vulnerable against denial of service and XXE. So it has 4 vulnerabilities. You can do some bad configuration and have more vulnerabilities. For libXML, you have a worse default configuration with denial of service, XXE, parameter-based XXE, and server-side request forgery. And you can also set the features in a very bad way. So, and for Java, we did Xerxes, Crimson, Piccolo, Oracle, Sex, and DOM. And the good thing here is they're all equally bad by default. So we only have to look at one chart. So they are all against denial of service, XXE, SSRF. And if you set features, you can do it even worse in Xerxes. However, the good part is there are also countermeasures available for Java, so you can mitigate all of these attacks. So here's a summary of the evaluation. If you look at the first column, you see there are a lot of yeses, yes, 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 yes. So it's about 60%. And the stars indicate that there are no countermeasures available. So you use this parser. However, you have to live with the fact that you're vulnerable to denial of service. For the second column, the XXE attack, you're at around 50%. And yeah, it's still pretty bad, but well, that's life. And for the more you go to the right, the better it looks. However, also the more complicated and the more prerequisites do your attacks have. So here's an evaluation results from my two colleagues. And here you see basically these results reflected, for the XXE attack. So you see here there are also a lot of vulnerabilities, like 10 out of the total service providers for single sign-on providers. So if you got questions to this part, you can talk directly to Vladislav and Christian. So what should you take away from this presentation? Of course, you should look at this table and check out which parser is the most secure by default, so you don't have to do anything if possible. Otherwise, check out where you might use a parser. For example, you have a library running in the background, or you might use a parser in XML encryption, where you first parse the encrypted XML and then you reparse the XML after decryption to access your element structure. And you shouldn't trust the API documentation. If you don't believe me, check out XML Reader from PHP. Yeah, you should test and verify it. So if we want to conclude our session, we started with it's just XML, what could probably go wrong? I hope you can all answer this question now, more or less. With the one sentence, yeah, DTDs are a problem and are still a problem, and the default parser configurations are still insecure in most cases. Also, countermeasures are not available, so if you choose one parser, you cannot mitigate these attacks. As Christian told you or showed you, or I hope he showed you, or the slides were expressive, that these attacks can really gain complexity, and you're not just starting with, oh, it's XXE, it's just a single line of code, but you can do take it into a C data element, hence and forth to an attacker, get it here and send it to there. And here's again the link to the XXE cheat sheet where all the attack vectors are summarized. And if you're scrolling on the page, you also see another blog post, which is a parser evaluation. There are these results summarized, and there are also links to the PDFs and the code base from this project. So there are all the test files and all the parser results in way more detail than we can present it like here. So, and this concludes our session, and we're now open for your questions. We didn't report it because it's right. The question was if we reported these vulnerabilities, especially for Java, and what the answers from the vendors were. And we didn't report any of these because it's not like an implementation issue in the parser, but it's a feature from the XML specification. So if you go to the current XML specification, you have these entities and whatnot, yeah, so it's a feature of XML, and it's, no? And they implemented it correctly. However, this opens the parser up to attacks. And the good thing for Java, for example, Xerxes, is they took care of this problem, like they implemented a feature disallow doc-type decal. So you have to be aware of this problem. The parser is not broken, the parser is great, but you have to set this feature and you have to know about it. So there's no point in contacting the vendor.
What I meant is suggesting to them to set security faults.
Okay, the annotation was to suggest to make security faults.
It would be really great. So if we could have it, it would be really great, and a lot of vulnerabilities would just never happen. But the problem is, I think we will not convince Java for changing their XML parser implementation. So I would agree to you, so it would be really nice if you just have a secure parser by default, and a lot of vulnerabilities that we've seen on the second slide would not happen just because people don't use this feature. So people don't use DTDs in most cases, but this feature is hidden, it's enabled, and it enables attacks. So it would be really great, and maybe it will change for new parsers, but I think for the existing ones, it will not happen. Actually, in this, the question is if there is a relation between the SAML libraries and the XXE attacks. The problem is it was a black box test, so we just tested a website and we do not know which library is actually used, so we couldn't gather which XML parser is used. So from my experience, I guess a lot of Java parsers were there, and this would match our results, but I cannot be sure, so it's just a guess. Okay, so if there are no more questions, thanks for the attendance.